Welcome. In this particular video, we'll be evaluating expressions with fractional exponents. Let's take a look at our first example. Evaluate the following expression, 1000 raised to the 4/3. In order for us to evaluate, we need to make the following connection. Recall that if you ever have x to the p over q, you can rewrite this one as x to the p power under the qth root, or you can actually rewrite this one as the qth root of your base, in this case x, raise that to the p power. So we're going to use this connections here. This is structures in order to evaluate this one. So notice here that 1000 happens to be our base. The 4 happens to be your p, which is your numerator. And the 3 happens to be your q, which is your denominator. And what we're going to do with the 1000 raised to the 4/3 power, it's very simple. We're going to rewrite it in these two approaches, and then we're going to see which one is more convenient for us. So we can say, well, here we have 1000 raised to the 4th power under the cube root. Or we can say we have the cube root of 1000, raise that to the 4th power. Now, in order to evaluate, I'm going to go to utilize this particular part because it's faster. The cube root of 1000 is simply 10. Why? Because 10 times 10 times 10 is equal to 1000. So you're looking for that particular number that multiplied by itself many times will give you 1000, and that happens to be 10. So the cube root of 1000 is just 10, and we still have this 4th power. Now recall, using exponents, that this can be written as 10 times 10 times 10 times 10, and that is simply 10,000. So one can conclude the following: therefore 1000 raised to the 4/3, it's simply equal to 10,000. Let's see a few more examples. Example 2. Evaluate the following expression, 16 to the 1/2, or 16 to the 1/2. Again, using the information from the previous exercise, one can rewrite this one as 16 to the 1st power under the square root, or you can say, let's change the order around, and you can say, well, I'm going to take the square root of 16, and then I'm going to raise the result to the 1st power. Here it doesn't matter which one you want to use. I'm going to use the second one, and I'm going to say the following. The square root of 16 is just 4. Why? Because 4 times 4 gives you the 16. And then we're going to raise that to the 1st power. Now, any particular base raised to the 1st power is itself, so this is just simply 4. And you can conclude the following, that 16 to the 1/2, it's simply equal to 4. So example 3, evaluate the following expression, 27 to the 5/3. Again, we can rewrite this one as 27 raised to the 5th power under the cube root, or changing the order around, you can say that this is 27 under the cube root, raise that to the 5th power. Now, you can choose one or the other. I'm going to choose this one to evaluate faster. I know that the cube root of 27 is 3. And then I'm going to raise that to the 5th power. And how do I know that 3 is a cube root? Well, because 3 times 3 times 3 gives us 27. So we're looking for that specific value that multiplied by itself many times will give you the 27. Check this out. 3 times 3 is 9 times 3 gives you the 27. Now, we have 3 to the 5th, so that translates into 3 times 3 times 3 times 3 times 3 when using repeated multiplication in that case. And this is 3 times 3 is 9, times 3 gives you 27, times 3 gives you 81, times 3 gives you 243. So we can say the following: therefore 27 raised to the 5/3, it's simply equal to 243. And our last example, evaluate the following expression: 81 to the 1/4 power. So we can rewrite this one as 81 to the 1st power under the 4th root, or changing the order around, you have the 4th root of 81, and we're going to raise this to the 1st power. So what is the 4th root of 81? Well, the 4th root of 81 is 3. So this part is just 3, and we're going to raise that to the 1st power. And how do we know that the 4th root of 81 is 3? Well, because 3 times 3 times 3 times 3 will give you 81. Check this out. 3 times 3 is 9, times 3 is 27, times 3 is 81. So we just end up with 3 to the 1st power. And recall that any number base to, or any particular base raised to the 1st power is itself, so we can say that this is just 3. And we can conclude the following: 81 raised to the 1/4 power, it's simply equal to 3. So in this particular video, we actually use the properties of fractional exponents and the equivalent statements to that, so we can rewrite the particular expression given to us, and then we use the properties of square roots, roots, and exponents to evaluate them. So thank you for watching, and have a wonderful day.